Okay. Okay. Welcome, everyone. This is the start of the Ru Ruby Junior Developer meetup. We're still working on Eloquent Ruby. This is chapter 27, Invent Internal DSLs. I'm going to go ahead and share my screen. Okay, so it gives us these three examples of rake, RSpec, and active record. Which are examples of internal DSLs. The rake is a build tool, RSpec is a testing utility, and Active Record is a database interface library. And the first thing it does is it makes a distinction between internal DSLs and external DSLs. Um, And so it's we're going this chapter, chapter 27, is going to start talking about internal DSLs, and the next chapter is going to cover external DSLs. Um, the difference between those two is that internal DSLs use the Ruby language, and you're building your DSL on top of the Ruby language. External DSLs basically say, well, what we want is a syntax that is not covered by the Ruby language. So instead, we're going to invent a whole new language, and because we're inventing a whole new language, we need to create our own parser because this language that we're creating does not will not will not adhere to the rules of the Ruby language. They're going to be different rules, different syntax. So therefore, it's going to require a parser of our own. Um, the so little languages for big problems. Um, Basically, this section is describing when to apply or that there are trade-offs when you apply DSLs. So what DSLs do is they strike a bargain. They're very good at being they're very good languages for very specific things. And so Ruby in general is a general purpose programming language. It's good for a lot of different things. When you invent your own language, it's going to be good for the thing it was designed for, which means that, Rake is going to be a good build tool, but Rake is not going to be a good testing utility or database interface library. Same with RSpec. RSpec is going to be a good testing utility, but it's not going to be a good build tool or database interface library. Like you're restricting the domain of the language to a very specific tool set, and it's not going to be good for anything outside that tool set. And even within that tool set, there are boundaries that you might encounter. Um, okay, so yeah, this is more of a description, uh, yeah, it describes what I've already talked about. Um, about the difference between internal and external DSLs. An external DSL is in the sense that the language is new, is separate from the implementation language. So, okay, the first example, dealing with XML. This is what XML looks like. In Ruby, we have tools for parsing XML files. One of those tools is RexML. And this first example is an example usage of RexML to parse this file. First, we create first we open the file. We give it a file name, and then we create a new document from that file name with RexML. Then we pass that document to RexML with the XPath utility. So here we're telling it to find the first instance in this document of the path document author. And if we look back at the example that was given to us, we have this XML file that has document at the top level. Underneath it, it has, well, title and author. So the first instance of author in this hierarchy is going to be J.R.R. Tolkien. Okay, so uh, in the final statement here, we just print out the author name. Okay, that was pretty simple. Next, we're going to do something that's, it's a little bit more code. So we're gonna for each so we're gonna do the same thing where we open up that file. We're gonna create a new document, a RexML document, and then we're gonna pass in the into XPath the method each, and we're gonna pass in the document that we created, and the path that we're giving it is document chapter title, and then we're just gonna print the each chapter title. So if we look in our example XML file, we have document, chapter, title. So we're going to print out a long expected party, and we're also going to print out a shadow of the past. Um, so it seems like the original file has misspelled Tolkien's name. This is the correct Tolkien with IEN, and the original document has it as EN, just EN at the end. So how are we going to fix that? Well, we're going to do the same thing. We're going to open up the file. We're going to pass that document to a new RexML class. So we're going to create that document. We're going to call RexML path.each on that document, give it that path. And then for each instance of that author name, we're going to correct the misspelling. And then we're going to print out the entire document. Um, so RexML is easy to use, but there's a lot of redundant code that we're writing in these scripts because if we look at this script, we're always opening the file, we're always creating this RexML document, and we're doing that for each, and then we're passing that document to the XPath for each of these. So are there some things that we could do to clean up this code and avoid the calling the same code or all that setup code time and time again? And yeah, so we could alter or we could create this XML Ripper class for helping us. It's going to be this utility class for helping us easily parse through XML files. When we create this file, the initializer is going to accept before actions, path actions, and then after actions. And it's also going to accept this block thing. So these are the method definitions on path. It's going to take the path and the block, and then it's just going to add it to this uh, path actions instance variable. Okay, so when how do we actually use this code? We're going to call XML Ripper.new. This is the class that we wrote up here. We're going to pass it a block. and we're gonna call, you know, the R instance on it. So this is uh, we're calling basically the XML Ripper dot on path method, and we're going to give it the path that we're interested in and the block that needs to happen on that path. So for document.author, it's going to print out the text of that author. And for document chapter title, it's going to print out the text of that chapter title. And then we call ripper.run, and then we give it the file name. And basically that's a lot less code. Well, we did create this class, but now that we have this class, uh, it's a lot less code to run the actions that we want on that document. So we can also, using that same class, we can also fix the author's name very easily. So we create a new instance of XML Ripper. We call on path for that XML Ripper, and then we do this action, which is to update the author text to the correct name or to the correct spelling of J.R.R. Tolkien. And then we define an after block, which prints out the entire document. So these hooks, these I would call them lifecycle hooks, and they're called lifecycle hooks in other contexts as well. I know JavaScript has this idea of lifecycle hooks, and so does Active Record. But basically, they define what happens before and after, and you know, and then the regular the on path commands. Okay, so so we haven't defined a language yet. What we've done is we've just defined this class to help us. It's a utility class, and because we've created it, now we have this code that is much smaller, much easier to read. But this isn't a new language. This is we've just refactored some code to make it easier to work with. So what makes a DSL? We're stepping over the DSL line. So here where I'm going to read this sentence. Although we didn't set out to create a new language, the XML Ripper scripts certainly have a declarative, specialized language feel to them. This is, and from this framework, we can start creating this DSL. Okay, so what can we do to make this feel a little bit more like a DSL? Well, we can get rid of this R. That's what we're going to do in this example. So we're going to use instance eval to evaluate a block that is given to the XML Ripper class. If we are given a block. So what's that going to do? That's going to make it so that when we provide a block, and we are providing a block, we are providing this do end block. We're going to call instance eval on the code in here. Okay. I think uh, we're gonna rely on I'm gonna rely on the book's definition of instance eval. Okay, uh, because it's non-intuitive. Pass instance eval a block, and just like call, it will execute a block. The difference is that instance eval changes the value of self as it executes the block. Say some value, some object dot instance eval block, and the value of self will be some object as the block executes. Thus, if you rewrite XML Ripper initialize method to use the instance eval, so it's basically when you use instance eval, uh, basically in this case, self will be the instance of this XML Ripper.new class. So in it changes what self is. So whatever class we're in, whatever class we've defined this block in, that's not the value of self. The value of self is internal is going to be uh, this new Ripper instance that we've created. So when we call on path, uh, we're basically saying self.onPath, but that self is uh, is the is the instance of this XML Ripper class, which has the method onPath. Okay, so sorry, I lost my place here. Okay, so I think we were here. Okay, yeah, so because we've removed the R's
The
here.
R.
Yeah. Getting rid of those pesky R parameters is a step forward in making the XML Ripper scripts more language-like, but it's not the only thing that you can do. Okay, so what else can we do? Notice how each XML Ripper script always starts with the XML Ripper.new line and ends with Ripper.run call. In an ideal world, you would get rid of all that boilerplate code, cutting down the code so that it looks like this. Okay, great. How are we gonna accomplish that? Well, basically, what we're gonna do, the plan for this is to move all of this code into its own separate file with its own file extension, and we're gonna evaluate that code from that file. So once again, we're going to use instance eval to evaluate that code that comes from that file, and we're going to include it in this method called initialize from file path, and we're going to call instance eval from the contents of that file. So what you end up with is this file called fixauthor.ripper. So you have a brand new file that you're reading from, which has the contents are going to be just this on path. You know, you give it that document. You don't need any of these calls. You don't need to create a new Ripper. You don't need to run that new Ripper because in our instance, we're going to take care of it in our initialization from file. So what we're going to do is we're going to set up a new Ripper. We're going to initialize from the file, and then we're going to run from fellowship.xml. So we're getting our commands from this file, and we're going to run those commands on this XML document. And now that we've set up this method to initialize from a file, that file is our language. That is our DSL, because we're abstracting away the fact that like, okay, we're creating a new instance variable. You know, we're running the that all the commands that we've initialized on this document. That file doesn't know anything. All that file has is the commands, the on path commands, the after commands, and it's still Ruby code. There's still Ruby code in there, but it looks like it's a whole, well, it's a domain specific language, is what it is. That's what we created. Okay. Be aware that Ruby internal DSLs are more of a state of mind than a single technology. So it's not that we put it into a different file. It's not that we created a class that helps us. It's basically this idea that you have a simplified syntax for writing out your domain or for coding your domain. Any programming technique that makes the job easier, that makes the code clearer, is fair game. And it's true for Rake. It's true for Active Record and RSpec. They all work a little bit differently. They have different technologies involved. The syntax is all a little bit different. The way they've structured their code to accomplish that syntax is a little bit different. And so there isn't one thing that you can say that will turn something into a DSL. But here we're just defining it as anything that makes your programming job easier, that makes the code clearer. Okay. You might, for example, decide that it would be helpful if Ripper users could specify the very simple XPath as part of the method name, like this, on document author, and then you give it the author, and then it prints out author.text. On document author is a method that doesn't exist, so it's definitely a job for method missing. So we're gonna anything that starts with on, sorry, this method missing is going to handle uh, any methods that start with on, and then you're going to split up the parts of that method name. So the two parts will be document and author, and then basically we're going to use those those two parts as our XPath path, right? So it's going to be /document /author, and that's the path where we'll be looking at, and and then this code block just defines what we're going to be doing with that path. And here we're just going to be printing out the author.text. Um, okay. So in the wild, um, so once you get the hang of internal DSLs, the inner workings of a lot of seemingly magic Ruby utilities seem obvious. So this is an example from RSpec. From RSpec, uh, this is this is now that we've know a little bit more about DSLs, we can say that this is probably a method call that takes in a string and a block. Um, here, so yes, it is a method call, but it's also a domain specific language where you're describing what you're going to do, and then you're going to tell and you're going to explain that it yields an element to the block, and then you're going to provide the code that implements uh, what you're describing and how it should do it. Um, so this is it says either, but it's both. This is both a structured description of the behavior of arrays, or it is a call to the method named describe. So it's both of those things. A call that passes a string and a block. Okay, here's another example, and this example is from rake. Rake, this is a method call to the method task, and it takes in, uh, it's going to be a hash. So it's going to be this symbol and then the some whatever values that it maps to. And in this case, it's going to be an array of dependencies. So the first dependency is going to be install program, and the second dependency is going to be install data. So when you call the default task, um, oh, sorry, yeah, the default task is going to be set as install program and install data. So when you call rake without any additional task name, the default task will do this, both of these programs, install data and install program. Uh, So again, we either have four task definitions, and these are task definitions, one, two, three, four. So we can think of them both as task definitions or for calls to the task method. And that's also true. These are also four calls to the task method. Um, one very elegant thing about rake files is the use of the hash literal syntax to specify dependency relationships. We already talked about this, how when you define the default task, you can specify dependencies. The dependencies will be both of these. Okay, great. In Active Record, this doesn't look like much, but has many authors. So this is an Active Record relationship that, or Active Record API that we're using here, where we have this class book that inherits from Active Record base, and we're defining this relationship between the what will be our table. It's a table called books, and this table called books has many authors. It also belongs to publisher. And so it's probably going to set up a primary key on the publisher side and a foreign key on the book side using this method call. Has many is a method call, and then it takes a, a symbol that represents the table that it's referencing. And this is a belongs to is a method that takes in a symbol of the other table that it's going to reference. Okay, active record migrations. This is even more simple. Like there's just this self.up method, which is we're basically setting up this interface that says if you have a method that is a class method and it's called up, that's going to get called anytime we create an active record migration. So when we call bundle exec rake db migrate, it's going to call this code. And then when we roll back our migration, this is what's going to happen. It's going to drop the table books. So here we're creating the table. If we want to do the reverse of it, we're going to drop the table, and yeah, it's just a very, very simple uh, interface that we've set up, and that's all we have to do is we inherit from active record migration, and then we override these methods, these class methods. So staying out of trouble. As useful and easy as internal DSLs can be, they do have their downsides. The first is that internal DSLs tend to produce really bad error messages. So here on this code, remember this is the code that we set up, and it has uh, its it lives in its own file with the Ripper extension. But when we use this code, well, it's a little bit broken because we've forgotten the do statement here. So on path, do, and end. So it's broken. Unfortunately, uh, we get the error message that ripper.rb has an error in instance eval. But that doesn't give us a line number. It gives us the wrong class, which is ripper.rb, and the wrong line number because that's not where this error appears. So instead, when we call instance eval, we can also provide a second parameter, and the second parameter is the name of the other file. And what happens is that when we do get an error and we have a broken command file, we get the file name here. So the file name is broken.ripper, and it's on line number 5. So that helps us find exactly where. So instead of looking in this class, ripper.rb, now we can go to this class, broken.ripper, or go to this file, broken.ripper, and look at the right line number. Okay, so uh, yeah, so the this this is a problem, but it's not the biggest problem. The biggest problem is that uh, is programmer over enthusiasm. You can go very, very far with DSLs, but once you start trying to break the rules of Ruby syntax, that might that might be an indicator that those are the limits of your internal DSL. And you might need some, if you really, really want to break those rules, you are no longer in the domain of internal DSLs. That is the domain of external DSLs. For instance, if we have this code and we say, well, this code is all right, but I really don't want these parentheses, and I really don't want these string quotes. What I want is something like this, where I call on path a space and then a forward slash, and I provided the XPath path, and then some other block of code. And we could think about overriding the division operator here and start parsing out based on the division, but it's going to be a really big change, and it's going to cause problems. And it's not Ruby, it's not normal Ruby syntax, and you're going to start getting into trouble, especially when you start um, including like spaces or other characters in your XPath. It's going to be really, really hard to handle those cases. Okay, so basically, internal DSLs are very powerful. It's one of the hallmarks of Ruby. You can take advantage of the flexibility to create internal DSLs, but you have to stay within the limits of the Ruby syntax. If you outgrow the limits of the Ruby syntax, then you're no longer then you should no longer be using the DSLs. You should be using external DSLs. And the other message in this chapter was that they are very, very powerful, but also because they are very, very powerful, they limit uh, a general purpose programming language to something that is domain specific. And once you start outgrowing the bounds of that domain or outgrowing the bounds of the language, then yeah, that's not what they're good at. Okay, chapter 28. How are we doing? Do you want me to keep going on chapter 28 or do you want to take over?
No, I was actually very okay with taking over, but we are out of time, first and foremost.
Oh, right.
Unfortunately enough, I don't know, we can first end this and then we start another one for chapter 28.
Okay, stop sharing.